This is my first talk at Ember Fest. So I'm very glad and honored to talk to 150 ambitious web developers today. Many of you are working in a team with other developers. All of you, I believe, are collaborating with specialists of disciplines such as design, UX, copywriting, backend, maybe QA, security, to deliver apps that your user will enjoy. That's why you do this job, right? Building a web app that no one ever built before, it can get pretty complex. We've been talking about it for 2 days now. It requires expertise, multiple specialists. And this is why we organize as companies when we want to deliver ambitious products like Qonto or Intercom or anything else. So we've talked a lot about Ember, the framework for ambitious web developers, for you. And I would like to talk a bit about a framework for ambitious companies, which may be for you too. So in the next 30 minutes, I'm going to try to convince you that it's all about creating the right conditions for learning every day. I'm Aymeric. I was the CTO of Qonto, the account that powers up your business for the last 2 years. Ambition is one of our company values. The other ones are teamwork, mastery, and integrity. We have an amazing team of 60 web developers. Quite a few of them are in the room or on the call. You can talk to them, and I'm not going to redo the sponsor announcement, but we're right there. I'm also a core developer of Django. If we go back 10 years now, that doesn't make me any younger, right? Django is a web framework, not entirely unlike Ember, except you live in the penthouse and we're in the basement, like below the API. So thank you for coming to the basement today. That's so nice of you all. So Django is a web framework for perfectionists with deadlines. And you can tell that it was created by journalists in 2006, because there's a period right there. And because in 2006, paper was still a thing and news had to go to print, and so journalists had deadlines. Anyway, so what's interesting here is that we have two concepts. We have quality. As perfectionists, we want to get things just right. And we have velocity. We want to get it done by the deadline without breaking a sweat, because we're good engineers and so we are lazy, right? Which brings me back full cycle to my job as a CTO. My job is to repeat this over and over again, because managers are here to repeat things. So this is the basic recipe for building a successful engineering team. It has to start with quality, with writing good code. Code that does what customers expect. Code that doesn't break in edge cases. Code that survives network failure. Code that doesn't crash. Code that's easy to maintain and easy to extend. Code that doesn't make me want to hunt down the original author until I get blamed and he said it's me 2 years ago. Happened to everyone, right? So once we get the hang of writing good code, we can think about writing it faster, which is where velocity comes in. And the reason is very simple. If customer has a choice between product A, available in 6 months, and product B, available now, they will pick product B every time, no matter anything else. This is literally how Amazon won. Amazon just shipped faster, that's it. As much as we hate it. So now we all know that it's kind of difficult to ship good code fast, even with Ember, and even with the whole ecosystem we have around it. And so if we pull this, we can be pretty proud of what we've done together. And then we're even more motivated to keep writing good code. And this is a virtuous cycle. So let's see how it fares in practice. You can see it coming. So everything here, it's actual screenshots from Qonto's system, right? It's real life. So this is about a somewhat complex component built by the design system team. They are skilled, experienced engineers. And we test it, and we have these 5 QA returns, and we have 32 more QA returns for a grand total of 37, which doesn't sound totally like good code, right? This is the postmortem on an issue that we had during development of a feature. So I anonymized the engineer who's in the room, by the way. He's really a smart developer, a guy who gets things done. He's an early member of the team. The guy literally got Qonto off the ground, right? He's the opposite of stupid. And the payload he got from the API was not what he expected, like rookie mistake. Okay, so we see this and we're all like face palming. How can this happen to him? 1 month later, API contract, blah, 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 rework, bigger blast radius. Now there's backend and mobile involved in the thing. And when you go down the postmortem, it says that creating a POC, a proof of concept, would take too long, which is totally the thing I was saying about starting with velocity and then figure it out quality later down the line, wasn't it? Well, anyway. So I'm not picking on the people. There are developers who do postmortems when a thing is 2 days late. They're like A players, not everyone does this. It escalates. Delivery is capital S stalled. The situation is not improving because we're waiting for final specs, and plus now we start fighting because backend thinks, hey, we can start building, and web is like, no, if we start building, we'll have rework and we will not take the risk, and it's not getting any better. Last one, I promise. We have a web engineer who is working on a refactor, and he works on it for 1 week, and then we realize that there's no value in the refactor, and we just discard his entire work, which was pointless, busy work. So I could go on because we have dozens of these, and as we scale, as we grow, it doesn't get any better. But we hire smart folks. You can talk to them. So why is this happening? So this is the point where usually I question my career choices, and maybe I should quit tech and farm goats. And then I was informed that goats are even worse than code in terms of frustration and the stink on top of this. So I'm stuck with tech, and now I have to figure it out. How can we, as a team, build products that we are proud of? This whole idea of quality and velocity and pride, it was super nice on that slide, but it's not panning out by itself. So let's recap. Everything is a mess. To be fair, when you grow 200% year over year, like Qonto did in the past years, that makes a bit of a mess. People are unreliable, which is basic reality. We have biological computers up there. They are amazing for adaptability, and they are not so good at consistency. And so as a manager, my instinct says, order is needed. I will set up the best processes. Everyone will follow them. Life will be good. Which leads obviously to this. Bureaucracy, right? Everyone's favorite aspect of the corporate world. And if I have to be fair, the engineer is just as good as the manager at bureaucracy. And he has a computer to scale it. So this is the engineer's bureaucracy, right? Humans will have to find their way through the controls performed by the machine, or else the machine will block their merge request, and the engineer can do that job. So now, as a developer, you are waiting 13 minutes for CI to confirm that your one-line change doesn't break a lint rule, because it takes 13 minutes to the machine to check 1 line of code, obviously, which is no big deal, because it's not on the critical path, because the whole engineering bureaucracy, I mean, the whole CI run takes about half an hour, and so maybe we should fix this. This is big company disease. When a company grows, complexity increases, and everything slows down or gets out of control, in short. And then people turn to processes and tools to restore order. And soon, everyone, smart people, we hire the best. Everyone is directing their attention inward. They're focusing on their processes and their tools instead of looking outward at the customers, at the very customers who made the company a success in the first place. And this effort aims at bringing things back under control. So in other words, it goes to building a system for asserting control. It goes to creating a machine that will literally control humans. And then everyone hates what they've created, obviously, and sometimes don't realize that they brought it upon themselves. And this is happening everywhere. You have seen it. I'm sure you have seen it to some extent. It's definitely happening to us. So we are going to try to understand this phenomenon. And to understand, we have to dig into the nature of what we're doing on a daily basis in our teams. Fortunately, we are doing some value-adding work that create values for our customers. We design software, we implement it, we release it to our users. Perhaps we publish documentation as well. This is what customers pay for, directly or indirectly, and our companies pay us for doing this. So a profitable company is when value for customers is higher than cost of engineers, and this is how value gets created, right? Hence, value-adding work. Then we have incidental work, because we don't just do design and code. We spend quite a bit of time on things like writing tests, refactoring, writing internal docs, which customers are not paying for. So everyone is thinking Mirage. Yes, Mirage, definitely Mirage. So no customer will pay for Mirage. We do this for just one reason. We believe incidental work will make us more efficient at value-added work. So now there's one last category. What could it be? So that's everything else. It has a name, and the name is waste. And I have very bad news for you. Waste falls in the category of once you have seen it, you cannot unsee it. So from this minute on, you are doomed to seeing waste everywhere around you, because waste is everywhere. Sorry, not sorry. This slide shows 20%, 20%, 60%, which would be probably an improvement for many companies. So what kinds of waste do we have? Defects, bugs, QA returns, reworks. Overproduction, needless changes, over-engineering, refactoring that creates no value. Transportation, so like manual steps in their own process. Engineers must move things from point A to point B, but frankly, the machine could do it. Waiting is the single biggest waste in software engineering. We wait for the dev server to rebuild. We wait for CI. We wait for other teams a lot. We wait for the design. We wait for the copy. We wait for the spec. We wait for whatever. We wait for backend. Inventory, slightly less obvious. Backlog, work in progress. All the things where we invested effort, and it's not yet in the customer's hands, so it's not delivering value, so it's waste. Unnecessary meetings. I could go on. Nice. Should I go back to the goats? Don't know. So, why does this happen? Why do you think this happens? How do we all, smart people, spend so much time, so much energy on things that don't matter for customers? It happens because we believe that the Earth is flat. Okay, I know that this world is actually flat, that's not the point. Waste happens because we hold the beliefs that just aren't true. So they're beliefs, but they're misconceptions. It's a bit tricky, so I'm going to walk you through an example. I'll take the example of the refactoring that created no value. So engineer invests a week of effort. We expected it would make it easier to build future feature in the app, and actually it didn't, so we discarded it. So the actual result has a gap with the expected result. That's a performance gap. Why? Probably because we didn't know how to evaluate if the refactoring would bring value. If we knew how to do this, we wouldn't pick a refactoring that brings no value. So that's a bit painful to admit, because we think we're experienced engineers and we know a bit about refactoring. But when you look at the facts, we didn't know. We made the wrong choice. So we start sweating. Why does this happen? Because we had beliefs on code patterns that turned out to be false. We looked at the new pattern, the old pattern. We said new pattern is obviously better. Like belief that is better. And we went on. If I simplify a lot on the actual issue, we thought that centralizing all checks of roles in the Qonto app, are you a company owner, an accountant, a manager, a user? So centralizing this was supposed to be better. And then we realized that when we just want a different UI for different roles, well, we can just put an if statement and not treat it like we treat access control. So we had a misconception about a specific aspect of writing good code, high-quality code. Once we get to this point, once we break the misconception and pick up the chunks of our exploded brains from the floor, it hurts. It really hurts. You attack your beliefs. You can bridge the gap in your skill. We can bridge the gap in our skills. We can tell if a refactoring adds value, and we can fix the gap in performance. Okay? But if you never go to the root cause, to the misconception, you will just get exhausted fixing the symptoms of the same problems, repeating over and over at an ever-increasing frequency as you scale. So this is why misconceptions matter so much. That was a bit abstract. So you may be wondering, in practice, how do I find these performance gaps? How do I go to the misconception? At Qonto, we have this intimidating system, which is modeling the perfect condition for creating value. I'm going to describe it. You don't need to read that for now. It's based on work pioneered by Taishi Ono at Toyota, an obscure Japanese car maker, which became the global leader in a few decades, essentially thanks to this. And it works across all jobs and all industries, not just manufacturing, because it's really a people development system. On the surface, you look at it, it may look like a delivery system, but it's a system that works when every team member, any one of you, is empowered to think about how they do their work and how they could do it in a better way. So that's why we think of this system as a thinking people system rather than the Toyota production system. Again, it's not a delivery system. So we model the perfect condition for writing good code fast, and then we can look at the gap between the perfect condition and the current situation, what we actually do. And this is where we have the performance gap. And then we can discuss why they happen by walking the tree of causes. I'm going to explain a bit what's in there. The roof represents the value that we want to create for our customers. We do value analysis to understand what customers would find valuable. It involves things like talking to customers. They don't tell you everything, but if you do value analysis on the refactoring, you can ask an engineer, hey, how much time would this save you on the next feature? If we had asked this, maybe the answer would have been 0, and we'd never wasted a week. And then we do value engineering, which is all about looking for the best solution, the best technical solution to deliver value at the right cost. And this is really where you bridge between product and engineering, and it's perhaps the trickiest thing that we do. In addition, the roof contains our goals, safety, that would mostly be mental health for engineers, quality, lead time, moral. So it's the same virtuous cycle, but it was independently. It's like different people ending at the same conclusion. And this day, we would probably add energy efficiency in here if we want to save the planet, because good code is code that doesn't burn more CPU cycles than it should, or doesn't spend more time in CI than it should. So I'll spend a bit more time on the 2 pillars. So the first pillar, it's about just in time. It means delivering to customers what they want, when they want. I swear I'm not going to use the word estimate nor the word deadline from now on. So in software development, anything that goes wrong and that is not tackled will eventually manifest as a delay, because we will rework until we're late, which is a performance gap. That's like a expected release date and actual release date is later. So we want to visualize what's expected when and how work is progressing. And we do this with Kanban boards. It's like simple, straightforward, optimal solution to this. And here you have the golden rules of Kanban. So you always start with what's closest to done, because this is the shortest path to putting new value, added value, in the hands of customers. So first in, first out. Then you never start work before finishing the current work. That's because if you have A and B to do, doing A and then B will get A delivered faster and probably B delivered faster as well, versus if you are doing them in parallel until you can ship both. This is a basic argument behind continuous delivery and agile, essentially. And you never, ever create a backlog. So I know it's hard, but there's no excuse. You do not create a backlog. So, and then it's just math. If you follow this rule, you will get one-piece flow, essentially the opposite of batch. So you work on one unit of work until it reaches to customers, and then on the next one. And so it's just a continuous flow of value. If you deviate from the rules, you introduce waste. It's math. So I see it in your head, but Aymeric, it's not me creating backlogs, it's my product manager. Okay, I have a solution to this. You create a box, a small box like this. And the product manager can put one unit of work, say one feature in the box. Not 2, not 10, 1. And so you ask them, hey, can you put the next feature in the box? And when you finish your feature, you take the next one from the box, which is now empty, and the cycle can go on. So there's 0 or 1 feature in backlog, but not more. And now you can create one box for each developer in the team, or one box for each pair of developers, depending on how you prefer working. And you are essentially learning how to work at the same speed between product and tech. Instead of getting work pushed to you, you are pulling the next item from the product manager. So this is why it's called a pull system. And trust me, it's a huge improvement in your quality of life. Bonus, you stop doing things like backlog triage, which is like the most pointless activity I can think of. So I'm not sure why anyone would inflict this upon themselves. It's beyond me. Let's move on to the second pillar, right first time. Right first time means no defects, bugs not allowed, no rework, no iterations. So okay, that's an ideal. We describe the ideal, and then we can look at the gaps between ideal and reality. That said, the software industry has a high tolerance to bugs and rework because software is malleable. You can just iterate on software. But that's a blind spot. We are desensitized to the cost of rework just because it's cheaper, but it still has a cost. It is still waste. And in fact, I think it creates a dramatic amount of waste with results like having QA teams, which again, I can't fathom why you would want to have a QA team. So here's how we fight that waste. First, self-quality. So we are web developers. We want to be right first time, and we do not have a QA team. So we must be able to tell if what we've done is right, if it meets our quality standards. That's hard to do on our own work, and this is why we have code reviews. Code reviews are sometimes performed based on beliefs, which may be misconceptions, and different engineers could have different quality standards. So it's not because you have code reviews that everyone agrees on quality. So what we try to do is to create discussions, meaningful discussions on quality. So we record potential quality defects, like these examples, and we discuss them. So for example, forgetting an accessibility attribute or putting the wrong copy, there are clear problems. So we can go straight to problem solving. And then we do root cause analysis. We search for causes of these problems in breadth. So we have a trick which is 4M, man, I copied the wrong line, method, I don't know how to do translations, machine, localize was down, material, the copy in the spec was wrong. So you see the range of causes. And then we search in depth with 5 whys. Why, and eventually you land at the misconception. So this builds a tree of causes, and then we can look for cheap, actionable countermeasures anywhere in the tree. But we don't need to address everything, that would be too expensive. And then we have other cases that are less clear-cut, like how slow is too slow? Is it a problem in an app at our scale to have 150 instances of a feature flag? I don't know, good questions. We should talk about this. Lastly, when we have quality issue, we want to minimize their impact. And we have observed that it's always cheaper to detect them early in the process. Because once an issue has crept in, everything downstream is at risk of rework, waste. So we are training everyone to raise their hands like this and ask for help as soon as they have any doubt on the quality of what they're doing. Is the design or the spec unclear? Are you unsure of how to do the data flow? Are you hitting unexpected legacy code? You just raise your hand. So it's super effective. So effective that we design a slightly cheesy custom Slack emoji for this. But if someone uses this in a Slack message, everyone immediately understands that it's a stop and fix. And we're trying to react before things go really bad, and you get immediate help. So it's like internal code for this. It takes training because it's not intuitive. Like, we're great engineers, we're going to solve it by ourselves. No, we're a team. We are going to solve it together. And I'll wrap up quickly with the enablers. You can think of problem solving as post-mortem. So I described the general outline when I was talking about auto quality. Standard, they're essentially living documents encoding our current knowledge and thinking about the best ways to reach a given goal. And visual management ties everything together by enabling us to look at the same reality, to see the same things in how our operations are going. And here's the foundations, it's Qonto specifics, are the company values. So at this point, I hope that you see how this is a people-oriented system, a system that lives up to the ambition of the Agile Manifesto, individuals and interactions over processes and tools. You can see how we switch from controlling, from process, to developing skills and to supporting. In short, it's all about focusing on customers to build what they need, focus on value, on visualizing lead time or quality issues, and fostering discussions around our mastery as ambitious engineers, and investing in problem solving to break down our misconceptions, explode our brains, expand our knowledge, build up our skills. And so that's why it's about learning every day. That's what we're doing at Qonto. I'm excited about it. I have to manage expectations. We have strong evidence that it helps. We see engineers developing new skills, growing fast in their careers. We see our team scaling quite cleanly. But all the issues that I brought up are real. They happen, and they're a small sample. So I'm not selling a pipe dream. I'm not selling a system that will solve magically everything that's hurting the quality of your product or the velocity of your team. Rather, I'm selling a rocky path up a mountain, and you never know what's after the next turn. So you just take your backpack, you go as a team, and you keep walking. It's a cliche to say that learning is an endless journey. What I believe is that the journey is going to be a lot more interesting, a lot faster, and possibly less frustrating if you adopt this kind of approach to learning. So you can try some of these things tomorrow. The things I showed about the Kanban, about the pull system, about alerting, about recording and discussing quality defects, all this, you don't need permission from your manager to do it. You can just ask for forgiveness instead. They might work, so try them. And of course, you want to try them with us, you can as well. Thank you very much.